Hey guys, we're going to go over this concept of margin of error today. So this is a brand new topic. We haven't seen this before, and here we go. So if you've ever heard of people talking about political polls or any kind of survey, you'll have heard the phrase margin of error. And we have a formula for it, which we'll go through in just a few minutes. But basically, margin of error is this z-score that we'll figure out how to look up, divided by 2 times the square root of n, which is our sample size. How many people did we survey? That's going to be our n. So really, the only challenge is to figure out that z-score. All right, so we'll just go right to it. Here's our question. So example 1 says this. So a survey of 300 Rogers students. So as soon as you see that, you know that 300 is our n, because that's how many people we surveyed. So our sample size is 300. They asked 300 Rogers students if they approved of closing the schools for the year. Here are the results. So 212 said yes, 75 said no, 13 said they didn't know, no opinion. All right, so the first thing that we have to do is figure out what proportion of our sample, the 300 Rogers students, what proportion of those students said, yeah, they approve of closing the schools. This is what we call our sample proportion. It's just taking how many people in our survey said yes, divided by how many total people are in our survey. And all we're saying in this is out of those 300 people, what percentage approve of the decision. So we call this our sample proportion, and it has a symbol. It's a P with a little caret on top, and you actually pronounce it, it's like a hat on top of the P. You actually pronounce that P hat. That's your sample proportion. It's not saying anything about all Rogers students, just these 300. All right, here we go. So our sample proportion is the number of people who said yes, that's 212, divided by the total number of 300, our total n, our sample size. And then we want to divide that and get a proportion. And so when you do 212 divided by 300, hope this is right, you get 0.707. So a little over 70% of these 300 students, just the sample, approve of that decision. Sometimes they might not even tell you how many said yes. They might just give you this percentage up front, this proportion. Okay, so we can write it as a percentage, and I'm going to here, just over 70% of the students approve. But I want you to think of it as a proportion. We're going to leave it as a decimal the whole time. All right, that's easy. We figured out what proportion of the sample said yes. Now, here we go. What we're going to do is say something about the entire population, all Rogers students, not just these 300. I know exactly about these 300, but I want to use this sample to say something about the bigger population. So this is our hard work. This is the part we've got to focus on. So I want to know about the true proportion of Rogers students who approve of this. So here's the idea. I'll use my sample proportion as my best estimate. If I had to give you one number, I would say, yeah, 70.7%. But I don't know for sure. That was just for these 300. So what I do is I give myself a little wiggle room, what we call the margin of error. I'm going to say, I think it's 70.7%, give or take, plus or minus this little bit. And we call that little bit the margin of error. Okay? So we do this in 3 steps. And the whole point is that we're using this sample to talk about the whole population. Okay? The real parameter, the true proportion. So we have 3 steps. We've already done the first one. The first thing is to find the sample proportion, which we already did, 0.707. Okay? And again, sometimes they might just give us that. Sometimes we have to find it a little bit. All right. Then here's the hard work. We have to find the margin of error. This is that wiggle room that we need to figure out. And they will always give us what we call a confidence level. We can never know for sure about the true population unless we ask all 1700 students. But just based on these 300, we'll say, I'm 95% confident, or I'm 99% confident, or I'm 80% confident, or whatever confidence level they ask. And here, they give us 90% confidence. So we want to be 90% confident in our answer. All right, so here's how we take that 90% and turn it into a z-score. So you want to think about our normal distribution. You can even draw it like this real quick. Slide this up just a little. And what I want is I want the middle 90%. I want the middle percentage to be 90%, which means what we have to think about is how much is in the tails. So this is 90% in the middle. How much is over here and how much is over here? So if you look in our formula, you'll see this number alpha. I'm not going to worry too much about that, but here's what alpha is. Alpha is if I'm 90% confident, alpha is the rest. So there's 10% that I'm not confident. Alpha is like the probability that I get it wrong, basically. Okay, so 90% confidence. So alpha is 1 minus my confidence level. So 10% is 90% is in the middle, so 10% is in the tails. And what I do is I actually take that 10% and I split it in half, because half of it is above the 90% and half of it is below the 90%. So if there's 90% confidence, 10% total in the tails, take half of that. How much would be in the tails? 5%, right? 5% over here and 5% over here. All right, so what I do is I look up the z-score for that 5%, that alpha over 2, or the z-score of 0.05. And what I do is I go look in the table. Now we're going to look in the table, and I'm looking for a percentage of 0.05. So I'm basically looking up this z-score right here. What's going to give me that z-score that gives me 0.05? And I know because it's below the mean, it's going to be negative, but I don't really care that it's negative. I'm going to use it positive and negative the exact same way. But I'm looking here in the table for 0.05. So I got 0.04, 0.05, 05, and 0495. And so this is one of those annoying ones where it's right in the middle. It's completely perfectly balanced between this one and this one. So my z-score is going to be 1.64, 1.65. I do exactly halfway between those two. So my z-score is 1.645. Here's the good thing about this. When it's 90%, this will always be the z-score. You don't have to do it over and over and over. As soon as you know it's 90%, that's always the z-score. Okay, so here we go. Our z-score for 90% confidence, z of that 10% cut in half, 5%, is always 1.645. Okay, always the z-score for 90%. All right, that to me is the hard work. Now we've got to use our formula. So our formula says margin of error is the z-score divided by 2 times the square root of n. So our margin of error is our z-score, 1.645, divided by 2 times the square root of our n, which we knew was 300. And so we're going to put 300 in the square root. And then we just grab a calculator and solve that. But let me make this point really clear. You have to put that denominator in parentheses or you're going to get it wrong. If you do 1.645 divided by 2 times the square root of 300 and you don't put those parentheses, it's wrong. Okay, you've got to divide by this entire denominator. So make sure you do that correctly. And when you do, we're going to have to round it off, but we should round to the thousandths place and you should get 0.047. Okay, so that is our margin of error. So we'll interpret that in just a second, but let me just make it clear what we did. We found our proportion. 70.7% of my sample said they approved of this decision. And then I'm finding my give or take, my plus or minus, my margin of error. So what I'll say is the real proportion is somewhere around 0.707, give or take 0.047. Okay? And so I'm going to write this. This is how my answer is always going to look. It's my sample proportion plus or minus my margin of error. And when I do that, it's going to give me a lower range and an upper range. And that's going to be the interval that I say I know the real proportion is in there, or I'm 90% confident. All right. And then once we've done that calculating, and we'll write this down in just a second, this is the sentence that we will always write every time for these. It's our interpretation, and it's just this sort of formula that we write down every time. Here's how we start. We say we are how confident are we? We are 90% confident that the true proportion, the real proportion of Rogers students, not just the sample, that the proportion of Rogers students, I'll abbreviate this as much as we can, okay, who approve of, what was our approval, closing schools. The true proportion, we're 90% confident that the true proportion of Rogers students who approve of closing schools is 0.707, just over 70%, plus or minus, and we'll write it just like that, because we're going to say it's this margin of error above and below my sample proportion. So 0.707 plus or minus my margin of error, 0.047. And if you say that, if you write that sentence, that's perfect. That is an A+ answer. I'm going to go ahead and always do this 0.707 plus and minus so I can sort of see an interval that I know my real proportion is in. So if I take 0.707 minus 0.047, I'm going to get 0.66, and I'll just go out to 3 decimal places. And if I do 0.707 plus 0.047, I'm going to get 0.754. So the true proportion of Rogers students, I'm 90% confident that the true proportion is somewhere in that range, somewhere in that interval. Okay, so I'm going to have a different video that shows working the back of this, working those problems. But let me just recap real quick. So you've got an N, you've got a sample proportion. They might give you the number of yeses. They might just give you straight out this number. And then we take that as our sample proportion, and based on our confidence level, we find the z-score that goes with that. And honestly, this is the hardest part, finding the right z-score. And I'll work those on the back in just a second on a different video. But this is finding that z-score, plugging into your formula, just the z-score divided by parentheses, 2 times the square root of the sample size. That gives you the margin of error, and that is your plus or minus value to get the true proportion of Rogers students. And so we say this sentence right here. We're 90% confident that the true proportion, I should probably have the word true there, the real proportion of Rogers students who approve is somewhere between 0.660 and 0.754. It's my p hat plus or minus my margin of error. Okay, hope that helps.